Discovery, go at throttle up.
Okay, what's going on, everybody? We have part two of the X-76 inspired Kerbal build. It's Wings Thursday? Wings with Thursday? Wings Wursday? How's everybody doing? You survived the tank watching? We might have more today. We'll see how it happens. But yeah, we're gonna go basically until we finish this build or we are summoned for some Texas tank watching down in Florida. How's everybody doing? Thrusters Thursday? Thrust Thursday. Wings per Thursday. Yeah. Yeah. You didn't survive the tank watching. Rip. All right. Let's jump in. Let me get the tunage up and running again here. Let's see. Let's go up here. Actually, you know what? We always start with that song. Let's go here. All right. Loxical. You're making a space shuttle in KSP inspired by yours, but it generally gets unstable below 700 meters a second. Is there a way to fix this? What altitude? What altitude? If you dip too far into the atmosphere too fast, it gets aerodynamically unstable. That happened. Well, it never did, but the real shuttle would do that too. It gets very unstable at high speed in in supersonic regimes. It's designed to fly hypersonic, right? So make sure you're not dipping. My big thing is, like, because this used to happen to me all the time, make sure you're not dipping into the atmosphere too much. If you fall in too far too fast, it'll flip out. Around 25 kilometers. What's your angle of attack coming in at that angle? Is your shuttle up like this, or is it down like that? Phil, you were out all yesterday, so I missed the Firefly launch. I'm happy for him. I really am, dude. I was starting to suspect monkey business, dude, but they proved me wrong, and I'm really happy. I've never been happier to be wrong. I love seeing the new, like, the new space companies succeed. That is, like, my favorite thing in the world, man. Shuttle, he said, where's Chris B? Yeah, right. It's actually warm here in old Massachusetts. So we'll take the sweatshirt off and let's roll. I think it was around 25 degrees, but I went up to 35 or 20 because I was flying it by field. All right, so the space shuttle blocks. So it seems like your entry is okay. Like, your entry trajectory isn't superbly shallow, right? Like, so some important things to understand about the space shuttle in flying through hypersonic down to transonic, etc., down to subsonic. All right, so the shuttle, right? The shuttle has it has a bunch of different control surfaces on the back. All right, so the first and foremost thing you got is elevators, okay, or elevons, right? They're not ailerons. They're not elevators. They're, because the shuttle is utilizing a delta wing design. They're both. So they're called elevons, right? Now, these ones are primarily used for pitch because they're the biggest ones. They have the most moment. These ones out here can be used for pitch, but they're also used for roll. Now, interesting thing, these also deploy down during re-entry to keep the shuttle to help with differential speed braking. Yeah, that's a control system. I actually never implemented it on my shuttle in KSP. But yeah, these guys can actually deploy down during re-entry to help yaw the shuttle, and if you deploy like one, right, it'll act as a speed brake and cause the shuttle to go like this. You can steer it that way. Now these ones are elevators for pitch, right, or elevons for pitch. You could roll with those, but I don't think that was in the shuttle's control system. I don't know. I don't remember. Now up here you have your rudder. That thing is pretty much useless during re-entry. In Kerbal it'll work, but it's pretty useless during re-entry. Seriously, the nose of the shuttle's in the way. This is not. It will eventually, at lower speeds, it eventually becomes aerodynamically relevant, and that's where the speed brake comes in. Up here, you have a speed brake, right? So you have a rudder that can do this, right? But it can also do this, it could do that, or it could do that, right? You can use that to control your angle of attack. And in fact, that's what the shuttle does during its landing. They pull the speed brake to get the nose of the shuttle up and keep it up during landing. You can see it's deployed right there. Now, here's the big one. That thing makes the nose go up, right? The side elevons are there to control yaw and roll during re-entry up there. This thing is a big one. There's this flap at the back of the shuttle called body flap. The body flap, one of the kind of the things, like, right off the bat that's easy to see is that it protects the engines during re-entry so they don't get zapped by plasma. But this thing it can deploy up or it can deploy down. When it deploys down, it helps you keep the nose of the shuttle down. You do not want to nose up too much with the shuttle during re-entry. So I never, in Kerbal, my shuttle, I never go above about 40 degrees. I start my re-entry basically with the nose of the shuttle pointed at prograde at entry interface, and as it goes around the planet, right, as it goes around Kerbin, right, because Kerbin's rotating, the shuttle angle of attack gradually gets higher. I don't let it go above 40. I actually bring it down to about 20 after it gets to 40, and then I fly the shuttle in. And that's an important thing to understand with the space shuttle. Or any re-entry vehicle that you make in Kerbal. It's a glider, sure, but that thing is designed to fly. You fly the damn thing. It's not like a capsule where you're just kind of rolling it around to kind of figure out where you're in, like, oh, you can roll it, you can modulate the heat shield, you got a little bit of cross-range capability. You can fly that through re-entry, right? So it's not just like leave it fixed, right, and just have it go through and you're good, right? It's very hard to get that right, even with the real one. That's why they have all these mechanisms in here to be able to steer the thing, that and the cross-range capability of the shuttle. But if you're having trouble with stability, right, and you're, like you said, the nose went up too high, and then my guess, Blocks, is what happened when you brought the nose up, that the thing went like this, and then tried to fly backwards, and then just flipped out of control like that. Use these. Use those to fly the thing, to make sure your nose doesn't go too high or too low, right, during re-entry. You go too low, you sink too fast, you flip out of control. You go too high, and the shuttle has it has what's called a compounding pitch moment at high angles of attack. If you bring the nose up too much, it'll do that. It will. That's because the reason why is because it's just a seesaw here. You have 3 gigantic 5-ton engines worth of, or 5-ton Mack trucks worth of engine at the back, right? There's like 3 semi-trucks attached to the back of this thing. Tail-heavy planes don't fly very well. This was Rockwell's way of getting around that. The body flap and the speed brake, coupled with the Elevon control systems, right? Now, the first thing I thought with your shuttle was that you probably dipped too far into the atmosphere, but make sure your control systems are similar. If they're not similar, you'll lose control of the shuttle. Also, make sure that your RCS has a good enough what's called moment control to be able to fly the thing, because up at 25, even up at 25, right, 25 kilometers up in KSP, there's still not a lot of air up there. Your atmospheric density hasn't really gotten high enough for your aero control surfaces to do a lot. They do work, but the shuttle wouldn't just stop using its RCS and then start using control surfaces. It was a gradual handover. With the flight systems, they shut off thrusters as they got further and further into the atmosphere, and that is from a primary source. That is not from like the space shuttle manual. I asked Mark Polanski about that, a guy that flew the space shuttle. I asked him with Sawyer next to me at the ISS RDC. I'm like, do you gradually like shut off the thrusters, or is it just RCS to control surfaces? He's like, no. If we went RCS to control surfaces, we'd crash. And I'm like, okay, it's a gradual handover. So just keep that stuff in mind. Yeah. Hey, Flykin, what's up? My issue is that it would oscillate left and right, causing uncontrollable rolls. Okay, you have too much roll control. So my shuttle here, let me show you. My shuttle, I fudged it a little bit, Blocks, because the SAS control systems in stock KSP didn't really compound the flight control inputs like I wanted.
Discovery, go at throttle up.
And that's why I told you about the outer Elevon control system. That's important to understand. So, let me find my Block 1 shuttle stack here, or just the Block 1 orbiter. It should be up here. Here we go. So, all right. If you deploy that, right? Now look at what I did. So, I don't like how the SAS handles control systems with this. I don't like them. So what I did, I buried a tiny control surface in there to give me better roll control. The problem here if you get unstable with roll, first of all, your nose is down way too far. Remember, the shuttle doesn't fly like this. The shuttle flies like that. All right, if you look at the nose cone, see, my nose cone is pointed downwards, right? Remember, the shuttle is supposed to fly with that nose cone into the wind, like that. It's supposed to fly like this. That's how she flies. Okay? If you're flying it parallel to the ground and you try to roll, it's going to spin out of control because it's not supposed to fly like that. The nose cone is supposed to be the point of the shuttle, right? See how even like if you look at the shuttle's nose cone, if this thing had a regular nose cone on it, right, like Starship, it'd be up here somewhere. The whole nose of the shuttle is bent downward because it's designed to fly with a higher angle of attack. The reason why is because you're balancing that freaking gigantic thing in the back, the gigantic engines. So if you induce too much roll like this, right, you put in too much roll, she's going to flip out. I had that exact same problem. My solution was to bury a small control surface in there, right, to just give me a little bit. Because I didn't like how if I set this to roll control, I didn't like how this control surface was it's too much deflection, basically. Too much deflection for roll control. And if we set it to roll and pitch, it doesn't compound roll and pitch the way I want to. The way I want it to, it still deflects too much. So I put another control surface in there. Another way to do that would be to write code for a control system in KRPC to override the SAS control input averaging system. And I don't want to do that. I just put another control surface in there. That's way easier. I don't feel like writing code for that. I mean, could we figure that out? Sure. But, yeah, I didn't want to do that. So, like I said, my shuttle has a buried control surface in there, and that is entirely on purpose to address the exact problem that you're having. I don't like how these elevons handle when you have pitch and roll active. This control surface here isn't trying to fudge it because I couldn't get this right. That is very much induced and on purpose. That was based off of flight data from me testing this shuttle. Could you put in a trim tab? My body flap is the trim tab. On the space shuttle, your body flaps are the trim. That's your trim tab. That and the speed brake. That's important to understand. The speed brake, so I have two rudders up here, right? The speed brake.
Go and throttle up.
The speed brake is your trim tab in the shuttle's design. And so is the body flap. The body flap is designed for to induce nose down pitch. Negative pitch moment is what it's called. And the body flap is designed to induce positive pitching moment, meaning this thing deploying makes the nose go up, that thing deploying makes the nose go down. Now, the other reason why the shuttle had this is because whatever you're coming down with, right, you might have to compensate for a payload in the payload bay. That's why those are there. That's the other reason why those are there. Compensate for differential center of mass. Because the center of, if you have a payload that you had to put up in the front of the payload bay for down mass for a down mass required mission, you'd have to shim it with the body flap. That is the other reason why the shuttle has clusters of thrusters on it. To induce differential moment, because you might have to compensate. Your RCS is your trim at hypersonic speed. It's your trim. Right? And keep in mind, fellas, during re-entry, the shuttle's nose thrusters are off. They shut those off. They're using ohms pods only during re-entry. The reason why is the RCS outgassing, the outgassing plume, so firing the RCS with a plasma shock next to it causes problems. Firing a rocket engine into plasma, unless it's supersonic retropropulsion, will have adverse effects. Basically, the plasma will force the exhaust from these rockets right onto the windshield. Yeah, you don't want that. You don't want hypergolic combustion byproduct corrosion on your windshield. That glass gets unhappy when like nitric acid gets sprayed on it. Does that help, Lux? Sorry, a little bit of a knowledge dump. Hey, Fluffy, 13-month resub. Making a functional Dream Chaser today? No, not quite. It might also have something to do with the center of pressure moving close to the center of mass. Yeah, Lava. Wait a minute. The only way the speed brake might help to keep the nose up is for it to create absolutely huge amounts of drag, which doesn't sound right to me. I haven't looked into it though. So, to be very clear, the speed brake really only comes a lot into play once you get into the low hypersonic subsonic regime. The reason why? The nose is in the way. You gotta remember, the shuttle's coming in like this. The shuttle has a big flat belly. That flat belly is shooting air out to the sides. There's not a lot of pressure up on top of these wings. Now, when you get into the low hypersonic subsonic regime, so like Mach 2, Mach 3, when it's coming back down, the delta wings do help. The reason why the shuttle has this kind of armpit wing right here is because it's designed, air is coming off the strake and it flips up and over the wing and causes a swirl. It basically makes a tornado that looks like this. It's on the same axis as the wing. And that swirl causes a huge vortex over the wing, which generates crazy amounts of lift, but it only does it for a short period of time before the shuttle stalls out. But that vortex happens in subsonic. The speed brake really only comes relevant right like Mach 2, Mach 1 into like subsonic. I mean, it does work, but it really does most of the business, Lava, right when it comes into landing. That's when she's doing the business. But always remember, guys, shuttle's supposed to fly like that. It's supposed to fly like that. You know, it's not designed. If the shuttle is ever going through re-entry like this, you got a big problem. It's not supposed to fly like that. Like, there are moments in the re-entry regime where it does have zero angle of attack, like when it's doing the flare maneuver in the subsonic regime going down to land on the runway. But for most of re-entry, it's designed to fly up here. Somewhere like that. It's like a pitch trim control surface. Yes, these are for modulating pitch moment and trim. Yes, correct. Hey, Myth, 80-month resub. But yeah, hopefully that helps, dude. Yeah, it does do that, Lava. Believe me, man, like, I know the shuttle cold. I don't... I have an autistic obsession with that, and I mean that in an endearing way. I love that damn thing. It's so friggin' cool. Like, this is the time where EJ glazes the shuttle hard, all right? So just, if you're not here for that, just wait 15 seconds. That is one of the craziest things we've ever designed. Starship has the potential to be better, but nothing is like that. It still blows my mind that that's a first attempt. This is a first attempt at a reusable re-entry vehicle. First attempt. Dude, they broke the mold when they made this thing. It's so good. I don't care what anybody says. This whole design, the orbiter, is genius. It's so ridiculously well thought out. I am amazed that they cooked this up in 9 years. Rockwell, dude, Rockwell knew what was good, man. The same company that made the P-51 in World War II made this thing. They knew what was up. They made the P-51. They made the Apollo Command Service Module, the CSM. Rockwell made the B-1B space shuttle. Brother, that's a heck of a track record right there. And boy, did they break the mold with this thing. I'm telling you, it's still to this day, that's like pinnacle of re-entry vehicle design. Every single other re-entry vehicle we've ever devised, no matter what the country or whatever, it can trace its roots to this, because that is such a good design. Should I get KSP2? No. KSP2 is abandonware. Do not do that. Now, to be fair, Pork Sword, KSP1 is abandonware too, but modders are keeping it alive. Do not buy KSP2. I'm 100% serious. Do not do that. It's abandonware, and it's a steaming pile of crap. This game is way better. Get KSP1, get mods, learn how to fly in space. And that's, I know I say get mods, that's a little weird coming from me. I have fun with the stock game, but KSP1 with mods, there is thousands upon thousands of hours of playability here. And then sadly, Boeing bought Rockwell out. Yep. Yeah, Will, dude, look. I'm gonna say this once, Will. I don't hold grudges too much, like I try not to do that. I try not to be petty. What happened with KSP2 is unforgivable. And it's unforgivable. Straight up. That's all I'm gonna say. Unforgivable. Like, that's it. That's all I'm gonna say. Unforgivable. Another interesting tidbit about Delta Wings and Flying Wings, since you don't have an empennage, a pitch up is done by deflecting the control surface upward, which actually reduces the lift the wing generates. There is an interesting NASA paper about that. Unforgivable. Like, the management decisions made by Take-Two, management decisions made by Intercept, it's unforgivable. I'm sorry, it's just... It's not just about, like, a game, dude. Like, this is you're playing with... Okay, this is very much my opinion, dudes. You are very much playing with children's futures here, with this game. KSP inspired an entire generation of people to get into aerospace, myself included. All right? If I had KSP when I was 7 or 8 years old, my life would be very different than it is now. Now, you know, you shouldn't live in regret or anything like that. But, you know, I rarely invoke like, oh, think of the children. But also at the same time, look, man, how many kids... If all KSP2 had to do was just be KSP1 with some better graphics and the ability to run higher part counts. That's really all it needed to do. And they just make it mod friendly. It's an easy W. Easy win. Like, it is a cash cow. Guaranteed. Now, how many kids... Like, this is how I think, dude. And, like, once again, I rarely invoke, think of the children. I usually say that as kind of like a mockery thing, right? But how many people are not going to get into aerospace because KSP2 was a letdown? How many kids out there are not going to play this game? You know, how many kids are going to go play Fortnite instead because Fortnite's better? How many kids out there are going to go play Mario Kart or something? You know, and nothing against those games, to be honest with you. But there's so much wasted potential. It is very frustrating. And I'm not saying that just because this is my job, right? I'm saying that because inspiring people and giving them the kick in the pants that they need to reach their full potential. Like, if you have a passion for aerospace, KSP is a great gateway to get into that when you're young, right? And we don't have that anymore. And that's why it's unforgivable. That it's unforgivable. It's unacceptable. It really means a lot to me, considering that me playing KSP changed the entire course of my life. Like, I don't take that lightly. I really don't. And I'm not really one to hold grudges either. Like, bygones be bygones. That one I'm sticking to. It's unforgivable. With that all being said, let's get back to work. I hope Kitten Space Agency helps, and that's why I'm helping them. That's why I'm a consultant on KSA. I help them with stuff. When they have questions, they come to me about certain aspects of the game. Yeah, there you go, Lava. That's what I mean. How many kids are not going to have that opportunity, dude? How many kids out there that love video games? You know, how many kids out there that, you know, don't have a lot of friends, you know, not very very socially awkward like I was when I was younger. How many kids out there are going to go play Fortnite instead, or go play League of Legends, or go play, you know, whatever the flavor of the month game is. I don't know. You're going to go play that instead. Just like I, when I was younger, went and played Counter-Strike. Right? Dude, if I had KSP when I was a kid, brother, I'd be Von Braun right now. Like, minus the, those parts. Like, that... It's unacceptable. It's unacceptable. Like, I'm sorry. Like, when you choose to uphold the mantle of an educational outreach game, you have certain responsibilities. You have certain responsibilities. It's not just about making money. I don't give a frick what anybody says. And the fact that it got reduced to making money pisses me off even more. Like, I don't do this job because it's a cash cow, okay? I don't do this job because it makes me $200,000-$400,000 a year. All right? It doesn't. I do this because I love it, and I do this because I give a frick. I give a frick about, people just getting sucked into playing video games all day like I did when I was younger. I don't want people to do that. Like, and if you can use it, I mean, the way I see it, people are going to play video games anyway. If you can use it to inspire some type of passion in STEM, then that's a really valuable commodity. It's a very valuable asset in money. That's a money maker in itself. But it has, like, if you're just motivated by cash, then a game like KSP doesn't make sense. Which is exactly what happened. And that's why it's unforgivable, dudes. It's unforgivable. It's not just about the game that I play and the lost revenue from my stream. It's about not being able to inspire another generation of kids potentially and get more people into the aerospace sector. That's what pisses me off the most about KSP2 by a long shot. Not even the fact that like I said, if KSP2 was successful, the trajectory of the stream would be very different than what it is now. Right? Like, I don't think anybody can deny that, but that's not what keeps me up at night. Hey, B-Dean, what's up? Yeah, exactly, Victory. It's unacceptable behavior. Like, I think about that a lot. I think about that a lot when I am, like, giving you guys analysis on companies and stuff. And honestly, it made me a little more cynical for a long time. It made me a little more cynical about things. Cynical about games, cynical about the spaceflight industry. And it took a while to mentally unscrew that, which sucks. There you go, Rares. The kiddos aren't gonna be able to ride the hype. They're not gonna be able to look for the next update for KSP2. Look forward to asteroid mining, or look forward to base building, or colonization, or whatever. It's... yeah, unacceptable. Now KSP1's just a niche game, which sucks. Because it could have been way more than that. Anyway, I'm gonna get another drink. I'm gonna get a drink of water. We gotta work on this thing. All right. Where we last left off, I needed to run another strut. What was the note that I left to myself? Implement control systems for slow ramp up of the main turbo shaft. Okay. All right. Are you partaking in any of the Goddard Centennial events? No, probably not. That strut right there. To run that strut again, so I did not run this strut in symmetry. That was the last thing we needed to fix. So that needs to go to there, and it needs to attach to that assembly. And then we need to make sure I'm in 2x. Okay, we are. Just a friendly reminder, the 3 p.m. NASA presser on Artemis 2. Yeah, I know, Binary. Thank you. I'm worried that that's going to interfere with tank watching, but I basically will play it by ear. Okay. That assembly goes there, and then this goes back to there, splitting the assembly like that. Okay, cool, good, good. So, if you're wondering what the heck all that is, so this is a DARPA X-76 inspired craft. I modified one of my old K-29s, which was my small VTOL craft. I'm modifying it into a tilt rotor. But if we look at a DARPA, hey baby. If we look at the DARPA X-76, guys, this thing, we went and found the patents for it yesterday. Actually, chat went and found the patents for it. How this thing actually works is it looks like there's engines in here. There's no engines in these nacelles, okay? The engines are in the fuselage, and there's a drive shaft that goes out to them, right? How the thing propels itself, right, is a drive shaft-driven turbofan in the aft part of the nacelle. A drive shaft-driven ducted fan, not turbofan, in the aft part of the nacelle here, and then a turbojet sticking out the back of this thing. No tank watching today. I don't think beach closers for tomorrow. Cool. Marcon, what's been going on with tank watching? Booster 19 is getting tested. We saw a tanking test on Tuesday and then a spin prime yesterday. Nothing today from what I can tell thus far, but we should be approaching a static fire for Booster 19. Hey, New Mark, what's up? EJ's notepad controversy would be links to pictures of the shuttle. Yep. So, just how this has the jet engines in the fuselage, I'm doing that with this design. I have two jet engines that are on the outside of the fuselage in this design left over from the previous version of the K29. But I have a singular drive engine right there, the R121 turbo shaft. A singular drive engine that's powering RCS gears that are made out of RCS thrusters to power the propellers. What I've been trying to do is get my gear mesh to be a smooth operation. So let me show you where we're at thus far. See last about USA Canada. What? I don't. What? Why? What does that have to do with anything? I don't see anything from you with a tag from me. I don't see a previous message from you, Outdoorsman. You're gonna have to type it again. Yeah, spoiled. I think he's on the money. Isaacman's decisions make a lot more sense in context to the OIG report and whatnot. USA Canada Friday for the third time in 30 days. It was near the beginning of the stream. Yeah, I don't see any message from you saying anything about that, dude. That's weird. It's very smooth operation. That's very minimal vibrations there. Let's ramp her up. Now, we're not trying to take off here. I don't think we have the power to take off. I don't have the control systems bound to be able to take off, by the way, as well. Yeah, that's acting like a cyclic. Whoa. So what I've been really testing is the ability to do this without the gear mesh mechanism screwing up. Yeah, I really don't want it to do that. Ooh. That's what I'm looking to avoid. You see that Isaacman said base construction starts next year with uncrewed robotic missions? No, but that's super cool. I'm wondering what happens if we lower the mesh here with this. Like we make the gears mesh a little bit more. Like what happens if we do that and bring the gears in together? Basically what the MV-22 Death Osprey should have been. Great idea to counter-rotate, but at a blade it equals the same. Yankee, the blades are placeholder right now. They're absolutely wrong, because these ones are spinning backwards, and the other ones are spinning the correct direction. And I have none of them bound up to a collective or a cyclic or anything right now. I'm just trying to get the gear mesh mechanism to work correctly. See? It just pops the gear. That's a shame. Want to make sure your eyes weren't playing tricks on you. Yeah. Yeah, it's not ideal. I mean, so what happens is that this thing is spinning so fast the game misses a physics tick. And I think that's why I limited the other one to only 400 RPM. But 400 RPM might not be enough for these things. That's the problem here. With helicopter blades, you can handle a lower RPM. With propellers have to spin at much higher RPM to be able to generate lift. Short story, blades aren't as big. Helicopter blades are much bigger. It requires more torque to drive them, but you don't need to spin as much. Propellers have a much shorter blade, right? You don't need as much torque to spin it, right? But they don't generate as much lift either. Look straight out of Fallout, though. Right on. It's always been a thing against the MV22 and things like this. It's so intricate. So, Jared, my thing is, dude, like, okay, just some food for thought here. Everybody hates V22s because they're so mechanically complicated. What about a Chinook? Chinook's pretty damn complicated. Everybody said, oh no, everybody loves that thing. Chinook gets one hit on the front rotor, you're dead. Like, that's it. It's just as volatile as a V22. And it has just as many moving parts, right? Except for the whole tilt rotor thing. But, like, everybody's like, oh no, Chinook's great. You know? Chinook has just as many gearboxes and drive shafts and differentials and synchronizers and control input systems as a V22 does. Everybody loves that thing. Come on, except for the tilting thing. Yeah, yeah, except for the tilting thing. Yeah, I said that already, Pogo. But the subject of discussion is not whether the tilt rotor is more mechanically complicated. I'm saying that, you know, one hit on the front rotor on a Chinook, you're just as dead as you are as a hit on one of the nacelles in a V22. Yeah, but Chinook doesn't crash on its own nearly as much as a V22. You guys are misunderstanding what I'm trying to say. Go back and read what Jared said. Same thing there. As an AE, I don't like propulsion systems ran on drivelines for aircraft. Leave that to the ground vehicles. See? Jared gets it. If you want to argue that the V22's tilt rotor mechanism wears out components way too quickly due to angular precession of blades, yeah, I'm not going to argue that one. Chinook doesn't do that. But if you're in a V22 and you're dropping in, right, or a Chinook and you're dropping in, one good hit on either one of the front or side rotors on the side rotor on the V22, front rotor on the Chinook, that's not going to end well. You know? That's the point we're trying to make. Yeah, with that all being said, yeah, the intricacies of a tilt rotor get in its own way, and but that's what the X76 is trying to solve, right? Today I learned the MV22 rotors are mechanically linked. Yep. Dude, there's two C-130 engines sitting out on the wings that have a transverse output drive shaft to a synchronizer. Dude, if you had blade desync with a V22, the thing would rip itself to pieces. And unfortunately, I'm pretty dang sure like that's the cause of most V22s going out like that, which sucks. See, Jared, I don't have any problem with a design like the X76, even the V22 in terms of drive mechanisms, because the drive shafts aren't near where the people are. You know what I mean? In the P-39, you're right. Yeah, the drive shaft went through the cockpit on the side to the propeller in the front. And the P-63 as well. If you had one bad U-joint, that's not going to end well for you. You know what? I want to try something. We're popping out the drive shaft here. We need a bearing with tighter, well, that can deal with the slop here. Chief Engineer yesterday, a viewer in the chat, suggested, you know, the fluid spectrometer bearings, and I'd said at the time that there's really not enough room for them. But if we did something like this on top of the wing, that could prevent it from popping out. Dumb question. Could you do the same design as a V-22 with additional jet engines instead of turboprops? No.
Discovery, go at throttle up.
Dark Chrono plan. I don't want to make an Chrono plan, dude. They don't. Ground effect doesn't work in KSP. Hey, Maddie. Rockets, more stuff, more fun times, more. Yep. Is there a way to make something do a complete mission with a Cal controller? You'd have some trouble, dude. Hey, Ugthick, what's up? We're getting so much damn run out, dude. Yeah, that one jammed completely. We did get this to be pretty dang smooth yesterday because, yeah, we need control systems for slow ramp up of the main turbo shaft. The Kraken deck is terrifying in this. I know, it's pretty awesome though, right? Pretty good though. Hey, that's pretty good. A spectro bearing might help us here. I'm just trying to think about how it would. How would we do it? We don't have the space to put it here because the RCS balls need to collide with each other. That's where we had it yesterday. And here, I'll put my main turbo shaft on a slow ramp. Incremental control, torque ramp. That'd be cool if you could use legit gears and parts and shafts. I mean, we could model them. I'm just not sure if a gear, like smaller gear Tesla Max, will do what we want it to do, you know? The other problem that we're encountering here is that the journals for this thing are just way too small to handle the RPM. Kerbal, so we'll start getting what's called run out with a drive shaft. It'll start doing this instead of actually spinning. It'll start translating on top of rotating like that. And when the run out happens, the bearing is hitting the thermometers, right? And the thermometer is such a small collider that it can spin so fast that the game, it'll miss. Kerbal simulation will be like, did it hit that or not? I don't think it did. And then it'll put it outside of it because we're getting run out. Basically, if we try to dial this in and get it as smooth as possible, we are less likely to have run out on the bearings. But the run out is happening because my gear mesh isn't continual. We don't have what's called a continual mesh gear. There's only so far we can get with it. Like, I could model a continual mesh gear and we could put it in KSP. It would look ridiculous, but we could do it. See there? We're getting no run out. That's perfect. It looks like past DJ
Discovery,
was
go
pretty
and
much on
throttle
the
up.
money. If you get... We basically have a FADEC for... We have a FADEC interpolating our inputs for this, but they're smoothing out the inputs and incrementally increasing it as I tap the H key. See right there? Just rotation. No run out. No skitching around. Now the problem is that this works all fine and dandy on the ground. When we're in flight, the blades are going to provide thrust, and that is going to put stress on the entire gear system. That's, you know, with this wanting to go up, it could desynchronize from the continual mesh from that gear. That's the other thing why I put this bearing down here. This bearing in this design, which is attached to the drive shaft, is acting as what's called a thrust bearing. Similar to a thrust bearing on the crankshaft of a car. And I can only hope that it holds it in place when we configure the blades to make this thing go up. That actually looks pretty nice. I can already see a shaft and a turner belt behind the motors. Is it possible to make a car-like engine? If you could figure out a way to force a piston down. I theorized being able to do that if you have rocket engines, right? You take rocket engines in Kerbal and make a cow controller, have them work on a firing order. So like 1 rocket, 2 rocket, 3 rocket, 4 rocket, and have it push a piston down. It's possible. You could make a car engine. You'd have to sequence a firing order with rocket engines on a repeating cow, but it's totally doable. Yeah. And then you'd need another cow controller controlling the modulation of RPM. So increasing decreasing the time step cadence between your firing order to basically act as ignition timing. You could do it. It just comes down to building a crankshaft and pistons and connecting rods that will be able to handle that. All right. I'm happy with what I see there. So when are we doing it? Soon. TM. Okay. Let's get our blades
Discovery,
configured.
go and throttle up.
I'm going to remove all the blades from symmetry on all sides of this. Uno Trezi, 21-month resub. What if you put the input gear for the props below the rotor output so the gears pull each other? Put the gear down there by the thrust bearing. That's another thing we could do. That's not a bad idea.
Discovery, go and throttle up.
Yeah, having it pull away 2020. No, that's not a bad idea, dude. But see, the other thing is that this is all very placeholder, because what we have to, like the X76, I have to make the blades stop in the right position and then retract on top of that. So the reality is that yeah, I mean, this is all in flex. I actually probably will do that. Yeah, I'll probably do that. If we have the gear down here, and then an axle in the center, or actually the spectral bearings. It's not a bad idea, dude. It really isn't. That's a good idea. Could also tighten the mesh under thrust. Yeah, Mutter, I'm kind of worried about that. Yeah, we could put that there and put the bearings there. And that'll give me room for the spectral bearing. But yeah, I want to try to use the thermal bearings just because they're lower profile. We'll see. But that's really not a bad idea, dude. It really, that's a good idea. All right, let's configure the blades. So let's reverse the direction of the blades. Rarest with the 99-month resub, thank you. Did you see the Starlab contract for Starship is at 90 million? That's $900 a kilogram starting out. Starlab? Hey Zad, what's going on? Another propeller on the underside? We could do that, but that's not exactly what I'm after here. The big single launch space station for Starship. Yeah, reusable Skylab, Trey. That's what I was talking about on the tank watching stream last night. Not the dumbest idea, dude. Joe, I'm debating whether we should do this now. 2020. I'm debating whether we should do this right now. I just got those gears to sync up pretty well. All right, you know what? Let's go to revision 1. I'm going to go to revision 1. We'll leave this version just in case. Let me make the modifications now. So what I want to do is we want to get rid of our thrust bearing, right? Get rid of this. We want to take this mechanism, flip it upside down. And put it there, like that. Keep the thrust bearing? No, make the gear the thrust bearing, dude. Combine it into one, save parts. That's why I was like, oh, maybe we should do this right now. And that also acts, the thrust bearing is the gear. That's a good idea, dude. Simplify, add lightness. Let's test it. Yeah, that you said it, and I'm like, that's not the stupidest thing I've heard, man. That's a good call. Let's see how it meshes. Yeah, Jared, I saved the old one, dude. Let's get this sucker working. Boom.
Discovery, go at throttle up.
$84-month resub from Vasia, literally 1984. What's up, man? How are you? All right, let's check the tilter mechanism. Let's see if it works. Bro. That's real smooth. We're getting no run out there, dude. Nothing. Good call, 2020. Good call. That was a good idea, man. Real good. Good job. Yeah, I mean, it's the gears tapping just a little bit, but it's not bad at all. Makes Starship already cheaper than Falcon 9 in dollars per kilogram. Keep in mind, that's what SpaceX bid, so that's based off of theoretically what they think it could be, Trey, but also, yeah, that's great. Wow. Glad I didn't waste 3 years of life studying mechanical engineering systems. It paid off with this Kerbal thing that doesn't exist. That's what Starlab is paying for it. It's a contracted launch service. Excellent, dude. Yeah, no, I'm cool with it, Trey. I'm cool. Like, dude, yeah, no. I've been saying Starship should be, you know, screw, like, commercial low Earth destinations is all fine and dandy. But, dude, have NASA buy 2 Starships and make both of them on-orbit laboratories, right? Send one up for 6 months, send 2 crews to it, you know, one for the first 3 months, a little bit of handover, one for the second 3 months, bring that thing back down, send up the other one, 2 more. Crews launch every 3 months. The Starship, you don't have to worry about human rating it. Dude, it's that's not like, oh, that's a really good idea. That's something we should just be doing. You have a Starlab, you have a Skylab style sized payload bay. Guys, all right, just a little bit of, you know, in case anybody wants to understand the context of what we're talking about over in YouTube chat. Skylab. This Skylab was an Apollo, so well, it was an Apollo mission, an Apollo applications program mission for building an on-orbit space station. What they did was they took a Saturn V third stage, they took the hydrogen tank on an S4B, made it into a space station, and then launched it. And where the LEM would be, they just put a docking port and a mount instead. See? Okay. That's a really cool idea, and then they sent the CSM up to it on a Saturn 1B. They used the Saturn V to launch this. They sent the CSM on this. Amazing idea. Really good, right? Okay, you see where that checkerboard is right there on Skylab? And you see the bottom of Skylab over there? Right? See that? From the checkerboard to here can fit inside of Starship's payload bay. This whole sucker can fit inside of Starship's payload bay. And when I mean fit, I mean you could take this and put it as payload inside of Starship's payload bay. you wouldn't be able to fit the docking adapter and the telescope mount or the solar panels. But this, the actual habitable volume of Skylab, could fit inside of Starship's payload bay. This thing right here is a 6.6 meter diameter. Starship is 9. You might, now, to be 100% honest, you might have to trim a little bit of the top here because Starship's payload bay tapers in because nose cone, right? But like 90 to 90, I'd say 95 to maybe all of it could fit in the payload bay of Starship. That's how big its payload bay is. Starship would be out here somewhere. And the nose cone would be over here, like that. So, what am I saying? Should Starship launch one of these things up into space? No. Starship should be this thing. Build this inside of Starship's payload bay. And instead of a docking port at the front, HLS style, put a radial docking port here. When Starship's payload bay doors open, you expose the docking port. Boom. There you go. On-orbit, reusable space station. You're done with the space station, want to update the experiments on board? Bring it back down, send up another one. You want your low Earth orbit solution for, Americans in space permanently? There you go. Since Starlab is a deployable station, it also means we're going to either get a space shuttle door or a fairing Starship. See, I don't want Starship deploying the payload. I just want Starship to be the payload. Simplify, add lightness. There's no point in having I'm saying this as a shuttle nut. There's no point in having Starship build a space station or go send a space station up there and then come back down, and then leave the module up there. There's no point in doing that. That's not a good idea at all. Starship is designed for on-orbit long loiter times because of its refilling operation. It's designed to stay up there. So why deploy it? Just have it be this. Have the whole thing be the space station. You could passivate the tanks, right? And then crew could be up there, right? Vent all the tanks, right? And then when it's time to land the thing, send up a refiller. Fill up the header tanks on Starship, bring it back down. Oh, hello there, me boyo. Chris, what's up, man? All right, let's rebind the collective here. The blade collective. So we want collective. Deploy angle. We need to set all of these to deploy. All 12 blades on both sides to deploy. So for the collective, we figured from our previous attempts that -8 degree downward on the collective controller is fine. And then we want 2.4 there, and we want 0 to make a dead zone in the controller. 2.6 there, 0 to complete our dead zone in the controller, and then +8 here up. Copy that over to all blades. And now, let me just check it. Do we have all 6 blades on this shaft moving? Yes, we do. What about over here? See, and I'm just going to say this before we do it. What I'm worried about is that we knew that this 12 rotor design worked when I had 2 turbo shafts hooked up to the mechanism, not 1. So if Starship is in vacuum in orbit, couldn't it slowly vent the tanks to vacuum without any structural issues? Yeah. Sure. The propellant's going to boil off 2020 anyway. It's going to boil off, so it'll keep your tanks pressurized. You just mitigate the pressure every once in a while. You have it vent. Imagine a deep space Starship-based probe to outer planets acting as a carrier, deploying smaller satellites on its way past. I would argue that an SLS with an EUS would be better at doing that, but Starship would be good too. I'm so tired, man. Late night take watching and moderating Firefly. How are you doing? I'm doing all right, man. Yeah. Does the diff yaw controller still work? It doesn't. Okay. I need to establish differential yaw here with these. In order to, the symmetry node is carrying it over. That's not great. Okay. We're gonna have to take them out of symmetry, and that could affect the design structurally, but for the differential yaw, I need this to move back -5 degrees, plus in a point at 2.4, right? Set value to 0, flatten that out, plus in another point at 2.6, set value to 0, flatten that out, and then set value to +5 over here. Rebind them. It bound it in symmetry. Interesting. That's really interesting to know. I removed the symmetry node and it's still... Okay, paste this curve there, but they can't move in synchronous if we want yaw, so this one has to be the inverse. So 5 to -5 over there. And if we want differential yaw, there we go. Killer. Now that cal controller, diff yaw, play position, normal control, normal absolute control. Excellent. All right, cool. SLS with a nuclear engine doing long burns for a deep space probe is what I want. I mean, you could do that with the EUS. That was always my argument for the EUS. I mean, it's good for human exploration. I would argue with human exploration, you need a better upper stage. But if you want to go ham on interplanetary probes, the SLS with EUS is a way to get stuff done expediently, because the missions actually get done faster because the transit time is lower. And that's better suited to an expendable super heavy launch vehicle. But nobody wants to hear that. Nobody wants to hear that. They don't like hearing the truth, I guess. I tried to say stuff like this on the last Flame Trench, and people were getting livid in chat. Like, I had some pretty heated discussions with some folks, but it's all good, man. Sorry. Not trying to be a jerk. Not too much, at least. And then I need to enable the cyclic control here on all these blades. Once again, what I'm really worried about is this thing not being able to make enough power to push this. And I'm not sure you can overclock a turbo shaft. So all my control systems are set up. Let's really put this thing to the test in helicopter mode. All right, Jeb, Your Honor, Your Honor. No way to extend the blades? Well, Yankee, the flight regime for this thing, so long story short is no. The flight regime for this thing is to be able to take off like a helicopter, think like V-22, right? And then what I want this thing to do is tilt rotor, right? Tilt rotor like the V-22, but instead of using the propeller, instead of using these blades as your primary drive mechanism, the X-76 has a ducted fan built into the back of the nacelle here. There's 2 ducted fans in there that are driven from the same mechanism. There's just a clutch that can shut the blade off, right? And then divert drive over to here. There's a clutch that can go forward and back to engage the fan or the propeller. And then you have a jet engine on the fuselage behind my head here for your forward propulsion. That's the idea. You stow the blades, it works a lot more like an airplane. Then the blades will deploy, right? And since you're deploying them knife edge first, it's not gonna be hard to get those things to deploy at lower speeds, right? And then you can feather the props into auto rotating up and then starting the turbo shaft. That's the whole idea here. So, because I have to get these things to work, I have to get them because we have to fly out like a V-22. I have to use propeller blades. That's the biggest propeller blade that I have in the game. The only blades that are bigger than this are the helicopter blades, and the helicopter blades, you can't feather them like you can't feather them past like 13 degrees deflection. With this you can with the propeller blades you can feather them so they work like they're spinning backwards, aren't they? Okay. Here we go. Dude, we just got to be cognizant of our RPM on the main turbo shaft. The yaw controller is inverted. Oh, we threw a gear. Not good, not good, not good. Well, Jeb lived. Okay. The differential yaw controller, we do not want that much deflection. So I'm going to say like -2. Let's dial that back a little bit. -2, +2. Change the curve. That was a little too much. The jerk from the yaw controller tilting the things threw the gears out of whack. We got to be more smooth in our operations here. So I don't want a lot of tilt between those things. Not a lot. And also we need to set the traverse rate on this thing to dampen out movement. We could set that in our yaw controller here. If we bring that down to 10% instead of 20, that should help it. Maybe bump that input down a little bit. Yeah, I know, I saw it. Other than that, everything kind of worked pretty well there. Also, it looked like my yaw controller was backwards. The differential yaw controller.
Discovery, go at throttle
It
up.
was backwards. We can inverse its input here. Inverted control right there. Go for a backflip next time. Yeah, I'll do something. Hey, Pork Sword, what's up? 2-month resub. Worked all the way to the scene of the crash. Yep, yeah. Yeah, it did okay. For a second. Can you make one on top and one on the bottom on both sides? Yeah, but if we're gonna do I could, simple, but I want a blade stowable mechanism. Doing that with blades facing both ways is gonna be, I mean, you could, but I'm trying to build something that's inspired from this. So I only want blades up top for now. Okay. Collective controller is working. Wait a minute. Something is weird here. It's going positive 2 to positive 2 through cycling yaw. That one's going positive to negative. Well, there's our problem. Yeah, that's why that broke. Something is wrong with the controller. I'm gonna undo my yaw inversion control that I just did. We're undoing that, and I gotta see 2 to 2, positive 2 to positive 2. Oh, jeez. It didn't take the negative 2 input over there. Yeah, that's why you should probably check your flight control surfaces here. So, collective is working. Now let's try yaw. Okay, that's working correctly. Alright, spool them up. RPM is steadily increasing. Once we get RPM capped out at 400, push it to maximum torque. Okay. I see what I did wrong. That needs to spin the opposite direction. The blades were spinning backwards, so when I went to increase collective, it didn't like it. You know what? I'd rather mechanically change the blades than flag a setting on the turbo shaft. I'd rather just flip them. That way I don't ever have to worry about making that mistake ever again, because mechanically the system will always work right. And it's not just something that you set on the freaking thing and could potentially change. You cannot change the blade position. Like, you can't adjust that when you're in flight, you can adjust that in flight. So that's why I'd prefer to do this. So now the blades should be spinning properly. Yeah, they were spinning the wrong way. All right, let's see. Okay, so let's test that yaw controller again. Yeah, that's what I mean about making changes. I don't like making changes to cal controllers, to your avionics, so to speak, in flight, because then you forget to do it when you're in here. Diff yaw is still backwards. That's still wrong. Let's go back in here. What's up here? That's +2, and that one's -2, so this one needs to be set to -2. I don't know why or how I missed that, but... All right. There we go. Okay, Wartaz. Not sure what that means, but all right. All right, so let's establish a flight regime here for this initial test. What I'm gonna do is not move so high up off the ground like I did last time. I'm gonna start up the engines, get the thing up, hover about 2 to 3 meters off the ground. Make sure we can go forward, make sure we can go backwards, and then make sure we can turn 180 degrees, and then turn back 180 degrees and land. That's what I want to do. That's just to test, you know, basic control systems here. Okay, engines are on. Gear mesh is engaged. Blades are spinning in the correct direction. Okay, wait till we have 400 RPM, increase torque limit. Okay, we are at full power on our turbo shaft. Okay, let's get up off the ground. Blurky gear. Rep down. Yeah, profile would probably be a better term. Mechanism totally broke. They're not spinning the wrong way. Oh, that must have been that Oridon. I think that's from the test that we did before. I got a spectro bearing here. That might work. Would there be a way to fold the blades? I have not even worked on the rotor mechanism. Got nukes. I haven't even worked on the stowable blades. The reason why is if the gear mechanism doesn't work, then our single turbo shaft design is out the door. That's not going to work. Right? Like, that was my rationale there. It actually looks cool. It looks like a rotary engine. I'm not sure how this is going to work with those, though. We'll see. You're making a burger, Portos? Yeah, all right. Hope you get past this part because I'm curious of the crack attack that will develop through Master EJ. I stand on the shoulders of giants, man. Yeah, see, it didn't work. It doesn't. It's too big. We're getting conflicting. Yeah, that's not going to work unless I change the gear ratios. Pink. My gear ratio that I'm using, and so here's where I'm at, guys. Do we want to try to change the gear ratio? We could. In fact, it would be better. It would be better if we made this gear bigger, right? It would be better. But that involves changing the amount of teeth that this gear has, and that's really kind of a black box that would take a lot of time to figure out how to get the continual mesh. I've been just having it as a 1-to-1. Now in reality, it would be a reduction gear. It'd be a big reduction gear going to the propellers. But if I made this gear bigger, it would be easier to get spectro bearing working. I could move this gear out a little bit, and yeah, we could go from there, and we would have more stability with this type of bearing, right? We'd be less likely to get run out with this bearing because the colliders are bigger on it because they're using spectrometers instead of thermometers, right? But also, I'm not sure how we would get them to mesh. Getting the gears to mesh is a big pain in the butt, dude. Meshing a ratio would be a problem. because just the way the teeth are on these things, that we've ran into that problem when we've tried to do this before. I know that that's an issue, so I don't really want to change the gears. So we're gonna have to think of something else. Are the thrusters pointed in with my design? Yeah, exactly, Mutter. It would have to be 2-to-1. A 2-to-1, or, yeah, 2-to-1 reduction. Or 1-to-2 reduction. Well, no, 2-to-1, 2-to-1. 2 rotations for 1, yeah. So this would have to have 12 teeth and be double the radius. It would look a little goofy, but yeah. This is the older version, guys. This is an auto gyro. But I have the engines outboard. The engines are out on the wings there. I don't know, maybe we should have just gone with this. This design's actually remarkably stable. But I'm noticing that my RCS thrusters are pointed inwards. I'm not sure if that's how we did this with my gears on the other design. And those gears mesh very well. Yeah, they are. It's the same. Okay. Aren't they a true spherical collider? Yes, they are a spherical collider, dude. Yeah, yes they are. But yeah, yes, yeah. They're sphere, but the shape is the sphere is like this. It's not the yes, yeah, for the most part, yeah. See, the other thing is that in my other design, the gears seem to be like that. In the on the AGR2, the gears are like that. Maybe that'll work. Put the thrust bearing that back in there, and then I'm gonna, yeah, we're gonna. I removed symmetry on the rotatos right there so we could get yaw control. And yeah, now we got to be careful. What we do to one side, they're out of sim. So what we do to one side, we got to do to the other. There's no more symmetry here. Hey, Starwalker. Long time no see. But how we say it in Brazil, who is alive always shows up. That's right. Okay. Same flight profile as before. Engines are on. Mesh gear is engaged. We're at max we are not at max RPMs. Let it ramp. Are the blades in sync? They're not. They're slightly out of synchronization. Let's try to limit our RPMs to 300. Okay. Guys, I'm gonna go ahead and say that this probably isn't the right way to do this. It is pretty cool, Troy, right? Yeah. There's just too much side fumbling. Like, have you read Eric Berger's SpaceX books? No. I feel like Sphere on Sphere is acting for misalignment. But the thing is, Mutter, like, dude, and maybe I just need to play Kerbal more. I got the other one to work. But the drives, your synchronizer is not your driver. It's just a sync. So it works more like a V22. But dude, take a peep at the auto gyro. This thing, I don't know if you saw this thing working yesterday. It works excellent. And this has the drives out here. But something to note, this thing never worked. It only worked for a little while if I disabled one motor and tried to drive it off of one. It never ever worked exactly correct. Watch. This runs, well, I don't know. I don't know what RPM this runs at. We're gonna have to look. And these things do stay in sync, which is pretty cool. And no, they're up at 400. My guess here at this point, dudes, is that the drive, each one of these having a drive mechanism, is what's helping the gears skip. What's helping the gears keep sync. That's my guess. having the drive come from the gear instead of being driven from that and just using that as a synchronizer is what makes this work. Because, yeah, this thing flies excellent, but this thing doesn't tilt. It's not a tilt rotor. I could make it into a tilt rotor if we really wanted to. Is the tilt what was messing with the sync? Believe it or not, no. It's the drive mechanism. See, that's the other interesting thing. Look at that thing. It doesn't even have an auto strut, and it doesn't move around. Look at that. If we tried doing this with the other one, this thing would explode. Now, with the X76 variant, we have this is not a light duty rotor. It's the turbo shaft. It's one of those things, and that's weeble wobbling all over the place. Now, I do notice that we have our... See, these rotors aren't powered out here. They are strutted together in this design. Yeah, see, this one, like I said, it has a synchronizer. The gears stay perfectly synced. And if you guys look, if I tell the SAS to compensate, you're getting very minimal vibrations being induced into the vehicle. The vibrations from prop desync show up on the SAS. This thing, you have a slight one when it comes to roll, but that's about it. Pitch and yaw are actually, they're very low, very high frequency, low hertz vibrations, judging by how the cow controller is compensating. The other ones, we have high frequency, high hertz, and that's just shaking the vehicle to pieces and desyncing the gears. The only real difference in the drive mechanism, guys, between this one and the other one is that I'm driving on their drives are on the propellers. It's like a V22 instead of like an X76. Jeb looks like he's having fun. How's Bob doing? Yeah, his head is in a fairing. This is my older design, Young Ninja. This is not a tilt rotor. It's an auto gyro. So these don't tilt. These motors actually shut off. And I use the jet engines for propulsion. And what these things do is they pinwheel in the wind, and that generates lift. It looks to me like the mass of the craft being put on the props that's pulling them out of alignment. Why does that not happen with this, Yard? Look, I can go up and down with this all day. We go up and down with it all day, and the gears don't even skip. Look. Even the run out, we're not skipping a tooth. What the hell did I do to get that thing so damn smooth? I'm really genuinely curious. See, we are getting, you could tell by the rotor that we're getting a little bit of funkiness going on here, but it's not a lot. Look at that. Honestly, guys, I'm thinking of just taking this mechanism and making it into the tilt rotor. There was really no point in trying to redo the mechanism. Well, there was a point in trying to redo the mechanism. It was to drive from the center here. So you have one turbo shaft in the center of the fuselage instead of two out on the ends of the wings. But the NASA pressure's in an hour, Sawyer. One thing I noticed for small rotors, the head can flex quite a bit from the base. The turbo shaft has a more rigid connection between the head and the base. Yeah. Maybe keep the outward drive units and extend the rotors up away to allow for tilt rotation and tests like that. Dumb comment, but are you hitting the programming limits of the game? We're not hitting the limits, but we're close, if that makes any sense. You have a lot less torque going through the gears with this design. Mutter, that's really what I think it is, dude. That's what it is. It's the drives being on the wings. That's it. And keeping everything in sync. The load being taken off this, and it's just being used to keep them in time. That's the big difference. And like I said, this has this almost the exact same gear mechanism. It's the same thing, and we're getting much less run out with this design. I mean, there's still a little bit. We could still try to deal with the vibrations a little bit better, but well, look at her, man. Dude, I would trust Jeb flying around with this thing in mission mode. I really would. This thing's excellent. If we could just get this thing to tilt and then stow the blades. Because this already has rotation. It already has the rotational servos in there. They're already there. When we change the flight mode, I could just unbind them from the yaw controller or disable the yaw controller and have a tilt controller in its spot, and then instead of a collective controller, we would disable the collective controller and have a feather controller. I could have just retrofitted this. And I'm thinking that's probably what we should do, just because of the limitations of drive gears in KSP. This thing is really a pleasure to fly. Probably could do with a ramp, though. Have you tried making Max a spaceplane in KSP? Was Dart based off of Max? Dart was my own design. The closest thing that Dart was to Lava would be the the X-20, the dinosaur. That was the closest thing. Have you built an SSTO to go to other planets? Not to go all the way to other planets, Bleaks, but I have built them, yeah. I have a pretty good one that's based off of Skylon. It's pretty damn good. Yeah, we could get a feather that way, 62. I'm not sure I'm about that life, but... Yeah, guys, you know, part of engineering this stuff, like, it doesn't matter if you're doing it in real life or, you know, in KSP or whatever, you know, I like the way that SpaceX does things. Nothing is sacred. If this drive works better and it's not it works better in KSP and it's not exactly like the X76, I'm not going to sit here and try to force that singular drive to work. I'm not going to do that. Let's do this. This works way better in Kerbal and it gets the point across. I don't think anybody's going to care about my stowable blade jet VTOL sprint vehicle if the engines are here or if the engines are there. You know what I mean? I don't think people care. Like, and I certainly don't if it's the difference between it working and not, you know? You guys will care? Oh, don't do that to me. It just needs to be pointy. It's not pointy enough. We can overclock the torque limiter on that motor. Question about helicopters that use jet engines. When they encounter back pressure on the rotors, I forget what it's called. How do they not stall the jet engine's compressor? Make sure that you're not exceeding the limits of the vehicle in terms of weight and carry capacity, Flykin. And yeah, upper limits to what you can and can't move around. The blades can absolutely stall a compressor. It's called blade stall. Once you hit blade stall in a helicopter, you're dead. You're not auto-rotating down from that. So how do they do that? How do they make sure that doesn't happen? Don't do it. Don't do it. You know, if a helicopter is designed to move 20 tons, how I would do it is engineer blade stall at 30 tons, right? That way you know it's never going to happen. Ever. I mean, I'm not sure why we don't just have the props attached directly to the rotors versus having the gears and all. Yeah, you're not sure, but here, I'll tell you, it's because that's what this thing does. This thing has a singular turbo shaft in here. There's a single turbo shaft that goes into a synchronizer gearbox and synchronizes two drive shaft outputs to another gearbox here that drives the blades, Yarg. This is not a V22. There's no engine out here. There's no engine out there. What there is, like I said, there's a drive shaft that goes to the propeller that has a detachable clutch, and there's a drive shaft here that goes to a ducted fan in the back of the nacelle. There's just a straight ducted fan right here. So this turbo shaft can operate as a turbo shaft like a helicopter, or it can operate as a turbofan, a low bypass turbofan. That assists with thrust to weight with a straight turbofan back here. I know, but I mean, you just said no one will care about how it's done, so why not just make it work? So I was asking, just why not just make it work? That's what I said, dude. I was like, I think we should just make it work. And you said, no, I'm confused. You should just make it work. That's how that conversation just went. There are autonomous variants in the renders, Ivan. I was asking about Max because I was watching Alexander the OK's video not long ago, and it seemed really cool. It would have used tri-propellant RP1 LH2 locks. I don't like strato launching things in KSP. It's really hard to get the recovery plane back. Yeah, Denny, I don't want to do that. I like to stick with practical aerospace, not wormholes. One exception is the Kraken drive, but... So, just on a side note, dudes, I noticed that my other design here had something like this. I had a strut that connects the two rotors together. I'm wondering if that was the difference. If that makes a difference here at all. So I'll add this into the design and we'll maybe mess with this a little bit more, but if I really can't get this to work, we'll go back to the other design with Oh, that's good. My capture card decided it didn't want to do capture card things and crashed my entire encoding rig. Lovely. Welcome to part 3. I'm telling you guys, I'm not very happy with that Elgato pass-through card. I'm not happy with it. It is pretty bad, actually. This does this fairly periodically. I don't know, it happens maybe once a month. I restart the computers every day and I update the drivers to avoid this problem, but it still happens. Very weird. It's an Elgato 4K pass-through and I don't like it. Yeah, I don't like it. I used a Magewell capture card in my old streaming setup design. I quite actually never had a problem with it. Ever. Period. Never had a problem. I used that for a decade. Fricking Elgato, get Corsair in here. You said Elgato would be better in 4K with better access to streaming and better uptime. It is faster over 5 minutes. Fricking Windows 98. Get Bill Gates in here. Ever since Corsair brought Elgato, things have gone downhill, and I like Corsair. Yeah. Avermedia is good too. I have an Avermedia card in the shop computer. Panderific, yeah. Pinche gato, sí. Sí. Chinga tu madre el gato. Sorry, not classy. Yeah, I don't know, man. Well, I'm just waiting here for a second to make sure that it doesn't kick the bucket. Sorry, VOD viewers. Part 2 just ended very abruptly. Oh, look at, there's some nice Windows noises that I have muted. Thanks, Windows. System sounds are muted, so why did a system alert just pop up? Sorry, guys, that was me if you heard that. I'm pretty sure you did. Deja Vu, you said that same thing yesterday on stream. What? Please configure Windows update delays to 2 weeks. I update the drivers. I don't like updating Windows. Oh, hang on. Chris B is pinging me. Oh no, not Chris B. Yeah. Let me fire Kerbal back up and we'll go. Oh, this is great. Yeah, great. That's... Good job, Elgato. Really appreciate you. That's lovely. Just... How crappy does your software need to be an auxiliary system on a computer and crash the entire computer? I hate, you know, guys, I ain't no software engineer. I hate how software is engineered nowadays. I know, what do I mean by this? People engineer software, back in the day, right? I know enough about software engineering to know that, like, back in the day, you were at hardware limitations. Hardware limitations on the computer. You could only, you know, you had like 256 megabytes of memory, or like a gig of memory a little bit later. You know, and you had 512 megabytes of video memory, etc., etc. You were writing software around your hardware constraints, right? Nowadays, you don't necessarily have that problem. And because of this, code is extremely sloppy. It's sloppy. Oh, I have a terabyte of RAM. Don't worry about it. Okay, there's 20 gigs loaded into memory. Whatever, it's fine. No. The software isn't tight. It's not tight anymore. It's just sloppy. And I know enough about software engineering to know that. I hate it. I can't stand it. This is that. I'm 100% sure. How does a freaking graphic or a capture card, like I said, an auxiliary system, crash an entire computer? What the hell do you have loaded into the memory to make it do that? Yeah, exactly, Snarfer. Who needs garbage collection, right? Who does that? Ridiculous. because Windows kernel is crappy at driver's isolation. Yeah, for sure, but like that's the thing, Deadbringer. Look, if you're writing, okay, my opinion, you tell me if I'm wrong. This is your domain, not mine. All right. Applying what I know about mechanical stuff to software, mechanical engineering and systems engineering. All right, dude, if you know the driver is caca, design around that. You know the driver can do that, so design around it. Like in physics, right? You don't design a rocket. Like, okay, so like with rocket science, you don't design a rocket to only fly on a sunny day, all right? That would be ideal, right? But could you launch in the rain? Yeah, probably, right? Or let's say an airplane, right? The 737. The 737 can take off in a blizzard if as long as the pilots are confident in the systems, right? Do you ideally want to do that? No. But you should take that into account because sometimes it snows. So you design around that. De-ice on the wings, etc., etc. You design around it. You don't, you know, yeah, you're right. The kernel is crappy at driver isolation, so take that into account, right? Clearly, that's not what's going on here. As a software engineer, you're so right, and AI is only about to make software worse because it does not care about performance at all. It's just, that's gross, Cuddles. I like, dude, that ticks my, it makes my brain go bananas. Like, I hate it. It makes my brain itch. It makes my brain itch! I can tell you from my professional experience, I have no professional experience. Yay for crap posting. I just had that happen. A Windows update corrupted my GPU drivers. It refused to boot, even refused to boot into safe mode. I had to use a Windows Media thing to get to a terminal and uninstall the driver GPU manually. Yeah, it's gross. It's like how games like GTA or Red Dead or, well, not Red Dead. Red Dead's okay, considering what it is. Like, you know, games are like 70, 80 gigs. Bro, texture compression? What's that? I don't know what that is. Your operating system, Windows, should protect you properly against a driver crashing. It's the same reason why you would have redundant systems. Microsoft should do better driver isolation. That doesn't take away that those writing the drivers need to be well versed in their work too. Yeah, and Deadbringer, we know that that's not happening. How's your day going? It's all right, Tweets. It was going all right until my capture card driver decided to crash again, and now I'm a little, you know, I'm a little bit pissed. I'm a little bit salty. Yeah. I'm a, you know, just a little bit annoyed. But, you know, whatever. But yeah, nobody writes tight code anymore, and it sucks. It shows. The quality has gone down completely. And like, dude, I'm not that well versed in software, but I know systems engineering when I see it. It's just write it and get it done fast. Guess what? Get it done fast did not work for the automotive industry. It's arguably not working very well. And guess what? It ain't gonna work for software either. Not in the long run. Freaking Windows 98! Get Bill Gates in here! I update all my drivers, Ator, to avoid this exact problem, and it still happens. What the hell's the point of updating the driver? And I've Googled it before. I'm not the only one having this problem. A lot of people have this problem. Yeah. Beyond salty, we're brackish. Yeah, that's right. Yeah, it's frustrating. No one writes tight code anymore, and it's annoying. Very annoying, actually. You were installing the student version of ANSYS environment on my laptop, and the whole thing is like 130 gigabytes. I know that good simulation software is heavy, but I also read that it now includes some AI things, so I don't know what the deal is. Alright, I'm just thinking about stuff. It's the same at your job. Our mobile devices have crashed once after updating its dataset before we were able to use it. The only response from our IT, yeah, that happens. We don't plan on fixing it since it doesn't interrupt you and your workflow. Alright. Deja Vu number 2 said last night, I keep thinking I'm not watching a live stream. You guys think Denny's watching a VOD and just somehow typing in the live stream chat but while watching a VOD? Because now I'm really confused. I had no problem. I said nothing about drivers yesterday or the day before or the day before that. I'm very confused at this point. I don't understand what's happening. Mem safe? No, me safe. Your mic is picking up a dishwasher sounding noise. That's Kerbal, dude. Or I have Starbase Live in the background. I always have Starbase Live on. The reason why I have it on as background noise is so the wireless headset doesn't shut off. It'll time out if it doesn't get any sound for a little while, and then I can't hear the sub alerts on the stream. There's also a massive shortage of taking pride in one's work today. Yeah, I know, Rares. That's a whole nother can of worms. Alright, it's Starbase Live, my bad. All good, brother. Don't worry about it. Okay, I was working on struts here. That was what I wanted to do. Let's just try to run a strut from here to here. That's what I did in the other design. Let's see if that fixes anything. Collective controller is on. Brakes are on. Gotta rebalance the audio there. Go. Okay. Verify yaw controllers are working. Yaw controllers are on. Okay. Start the drive. Can't for the life of me figure out why this one doesn't work. It's basically a copy. It's a copy of the other one, except the turbo shaft is there instead of here, and I have a small rotor attached to the blades instead. It still runs out like crazy. Am I missing? Let me just go through the collision groups here. Okay. Okay, those all have SVI on. That does. That does. What about you? That does. Okay. Same vessel interaction. What about you? You guys? Yep. Okay, let's check here. Okay, that all has it. Hang on, let me check the other vehicle. I think I got something. Hold on. I'm guessing the pass-through is for VR. No, the pass-through is for 4K, Mutter. Hold on a second, fellas. So I have, on this design, I have the drive bearing here. Now, is that attached to that? It's not. That is attached to that, and that is attached to that, and the gear, that nose cone there is attached to that. On my design, I have, it's not in parallel like that. This would be attached to that, that would be attached to that. Maybe that's the difference. Maybe that'll... NASA conference in 30 minutes. Yeah. Okay, that's a slight change in the hierarchy. Let's see if that fixed anything. Oh, I also... In my other design, this strut wasn't attached to the gear. This strut piece... This strut piece was attached to the pivoting mechanism. So... it was that. Let me just make sure I do that on both sides. Like that. Okay. Now let's see if this thing runs out. All being child to the same parent would increase stability. I think so, Pender. Yeah. I mean, that's... Once again, we are getting awfully close to just basically a copy of the other design. Hey, once again, with the exception of the drive engine. Let's see what this does. Engine's on. Control surface checkout. Okay, control surface checkout is good. Collective control is working. Okay, spool the engine. Blades are out of sync. I copied this thing. And the child parts of the gear teeth did not take same vessel collision. So we had huge desync. Something else? What's up, dude? Didn't know this had copter type things. This is modded. No, this is just the DLCs for KSP. Yeah. Breaking ground and making history. Yeah, you can do a lot of cool stuff with this. Yeah, I love building rotorcraft. I think that's super fun. Control surface checkout is complete. We have collision on both gears. Okay, starting at the engines. Ramping. Interesting. Changing the auto strut broke it. Oh, it's because if you switch it to heaviest, it tries to run a strut to the propeller. Okay. Interesting. Those are in series as well. Oh. I know the drive shaft is in a different spot on the other model, Fluffy. I'm not 100% sure if that's going to do that. Yeah. The only reason why they're lower is because I retrofitted the synchronization mechanism to the vehicle as a prototype. And the synchro worked. It worked really well. Yeah, it was kind of added after the fact, so I kind of kept it in a spot where I could see it, right? No, not your bad. That you definitely noticed it. No, I'm not saying apologize or anything, dude. You're right. Something else, you haven't played it for years, but you really enjoyed it. Dude, yeah, you can do all with mods. I mean, just with the DLCs, you can do crazy stuff. I was building launch pads with the mods, like, you know, transporter erectors and like firing off my own rockets from my own custom launch pads and stuff. I even got Kerbal constructs so I could make flat ground so I could construct more launch facilities, which is pretty cool.
Topped off, and there's a really good discussion.
Timmy ran the numbers. Nice on the moon stuff. I had a conversation with Tim Dodd on at the end of the tank watching stream last night. It was pretty fun, dude. Excuse me for a second. Yeah, we were. So, guys, what was going on? And I said this in the back channel. We were running out of things to talk about. So I started talking about HLS tanking flights. If Starship can move 100 tons into Leo, we've had that conversation on stream. And yeah, I argued just honestly, like, I know it's more than this, but I did it just to fill air, to have some fun, like, to just have a discussion about it, like, about how Starship is not going to need as many tanking flights if you can move 100 tons to Leo. Like, and Tim and Alex are both like, no, I don't think that's right. And then he started crunching the numbers, and then he tweeted about it, which is cool. That's neat. What's that, Booger Spoon? Interesting. Yeah, Tim's a good buddy of mine, Lemon Space. I haven't talked to him in a little bit, but I got to talk to him yesterday, which is pretty cool. That's cool. So what car is Tim trying to fix? I don't know. Tim Astronaut, the everyday dot? Oh, yeah. Didn't have SVI enabled there. I'm just going to go through a collision action group collision check here just to make sure that everything is right. Okay, seem to be good. Let's see what it does now. Perks of being a celebrity, I wouldn't call myself that. I just like spaceflight. I just have conversations with other people that like spaceflight as well. What's the issue you are having? Denial, I'm trying to make a synchro. Well, not a synchronizer. Obviously, I want my blades to be synced in a twin rotor design, but I'm powering it from a singular turbo shaft, and I'm using RCS as a drive shaft. My RCS is attached here and here, and the thermometers are being used as journals. And then I have RCS being used out here as a gear. So, if I ramp the engine, watch, it'll drive the propellers. I have a single turbo shaft powering 2 propellers in KSP. I'm trying to make a tilt rotor, because what my expectation is that I'll do it in slow motion so it's easier to see. I also need this to be able to, the whole thing be able to tilt forward. But see, sometimes the gear teeth don't mesh right. It's hard to basically hold this thing in position. Space shuttle. There we go. Let me check something. In my other design, dudes, I remember I have this attached to the wing. These struts are attached to the winglings. They're not attached, it's that. They're attached like that. They're not attached to the fairing. Let's try that. Instead of being attached to the fairing, let's see if that works. That was another. I'm just what I'm trying to do now is trying to note all the differences between the one that works, the auto gyro that works with a similar mechanism, and this. Yeah, Blark, I did. I was trying to make an intermediate bearing to prevent that run out problem, but it seems like it wants everything over there. I might need to change that. And that's, yeah, I might need to do that way. Nah, 62. Well, let's try Blark's idea first. I'm not sure we have enough time to fix it, but... I also think that this fan shroud is causing issues. I think it's causing problems. Why would that be strutted to there? That's not... Oh. That's very much strutted to the wrong thing. So yeah, that's very, very much strutted to the wrong thing. Give me 1 second. Let me fix that. The rotor edge, this thing needs to be there. It needs to be attached to that one. Like that. And I do believe the rotor is still in symmetry, so we should be able to attach it in symmetry like that. 5 minutes. Yeah, I can read the clock. Thank you. I don't want that attached to there, because that one is attached to the rotor mechanism. This could prevent... Having it attached to the spinning gear could prevent runout. It could prevent it from doing what it's doing. That could be the key, because I know that that's what it's like on the other design. And that one's strutted to the rotor box. All right, last test before the NASA presser. Let's see. Collective control is working. Yaw controller is working. Ramp the turbine. Didn't do it. It didn't really make that much of a difference.
Hello everybody, chat, Fiber5 in chat.
Rapticide time. NASA's live. Are you covering the press conference? Yeah, sure. Whatever. I'll fix it some other time. That's gonna do it for part 3. Yeah, we cover the press conference. I'll see you guys in a second.